In Dominion's original system of pressurizer for a nuclear reactor, you will see that the water is traveling through what looks like a loop. This means that the water is really just circulating at different temperatures. This loop is called the primary loop, and in this primary loop there are two pipes carrying water at two different temperatures. The top pipe is carrying water at 600 degrees Fahrenheit, while the bottom pipe is carrying water at 530 degrees Fahrenheit. I know this water does not seem like it is too cool, but the bottom pipe is significantly cooler than the top pipe. If the temperature changes in either of these pipes, the pressure must change, or else a crack will form. Speaking of pressure, the pressure is remaining at 2,250 psi.
From what we know of Dominion Power's presentation, a pressurizer keeps the reactor coolant system of pressure maintained and regulated by using heaters and valves to balance the mixture of steam and water. And within the reactor core, neutron-absorbing control rods are positioned inside, and when removed, increase reactor power and heat reduction, and when removed, vice versa. One innovation that could be made is by creating a system in which the positions of these controlling rods are manipulated by a piston. These series of hydraulic pistons would maintain the water pressure in addition to the mix of boron already being used as a coolant within Dominion Power's reactor vessel.
Here we have our nuclear pressurizer. In this design, we found that a way that we can maintain the pressure in the reactor vessel at 2,250 psi. And a way that can be done is we can install a bypass located here, following through to right here, where we can get 530 degree temperature to go directly right here. Although it is 530 degrees, it is much cooler than the 600, allowing the pressure to stay much decent.
Temperature is a measure of the average kinetic energy of the particles of a substance. When the particles have high kinetic energy, the temperature of the substance is high. Pressure is the normal force acting on the surface per unit area of that surface. At a molecular level, pressure is due to the collision of atoms with a surface. After inspecting these definitions, we are able to deduce a relationship between pressure and temperature as well as volume. When particles have high average kinetic energy, they have greater momentum and collide more forcefully with the surface. Thus, pressure created is larger when temperature is higher. Pressure is therefore directly proportional to temperature. If the quantity of the substance was kept the same but the volume of its container was increased, the rate at which the particles collide with the walls of the container would decrease. Therefore, pressure is inversely proportional to volume.
A nuclear reactor is used to sustain a nuclear chain reaction, whereby a radioactive isotope like uranium is broken down into smaller parts, barium and krypton. In doing so, a tremendous amount of heat and electromagnetic radiation is generated by the process itself, classifying it as an exothermic reaction, which then goes on to heat a tremendous amount of water that we use to power the steam turbines.